So let me start the webinar. I'll talk about myself a little bit. My name is Sitaraf Tadepalli, and I have around 14 years of experience in IT, and out of which almost 7 to 8 years of working in the data area. Been a big data architect for 4 or 5 years, and then after that, I've become data scientist. So from the past 4 years or so, I'm working in the data science area. And today's workshop, I'll be talking about data science. It would be more or less like an introductory workshop, but I will try to give up my experience in terms of a very lucid way, so that you can understand like what are the goods of your data science, how the field is trending, how it is changing the world, and how are different business applications using it for greater good. So without any further delay, let me start the webinar. If you guys have any questions, as Raj suggested, you can use the chat window to post your questions. We will take a break probably after the webinar. I will look at all the questions and then answer them. If there are any questions which are very relevant to the topic, probably I'll look at the questions and then answer then and there. Okay, so in case the questions are not answered, if you feel to wish me stop for some reason, you can use your microphone and then ask questions. Great.
Yes, sir.
So the topics for today, we will discuss briefly about what is data, introduction to data science. We will understand how the data science have evolved over the years. What is the understanding of business analytics and business analysis? We understand different classifications of analytics, like how they work in the real world. We look at the data science entire pipeline or a workflow, and we will cover different tools which we use in the industry for doing data science work. I'll also give a light on some of the current trends and market demands of the data scientist, like how the market is uh, you know in dire need of the skills of data scientists, and people who are becoming a data scientist get the very lucrative salary in the market. We will also understand like what are the different roles of a data scientist. Like if I say like this is a data scientist for an entry level person, what will be the role? For a mid level associate, what would be the role? And the senior associates, what will be their roles? Right. So we'll discuss about different roles of data scientists. And then after that, I will also cover some applications of data science, right? So we'll see like what are the different application areas in different industry verticals, and we'll touch base upon that. So what is data? So if I go to the Wikipedia definition and understand what is data, it says that data is like multiple pieces of information which is in varied forms and various shapes, ability to store that, and it is in the form of paper, bits and bytes, in the electronic memory. It could be information of a person, like for example, Aadhaar card information about every citizen of India could be a valid data and could be stored in certain tables, databases, and so on. And it could be an MRI scan taken by some famous hospital or a medical diagnostic center, or it could be a satellite image sent by one of our satellite stations which are revolving around the Earth. Right. So you can consider data as is in different forms. So a lot of information is being gathered for many years, and all this information is aiding for doing some business benefit, right? So we are trying to create a lot of information gathering for many years for benefit of the business, benefit of the mankind, and so on. And all this information is used in varied forms. One thing which has changed in the current scenario is now the data is available, but now the availability of data has increased tremendously. Right now, people are using internet, people are using mobile phones, people are trying to create data. You might have heard about things like Internet of Things, Alexa devices, and all these things. What we are doing is we are trying to generate data which we have never generated in the past. Like if you can fast backward, like in can just go back 5 years, and then you can just imagine that we never had so sophisticated mobile phones, right? We were not having smartphones some years back. We were not at all having phones like 20 years back and so on, right? So back those days, the data collection was very, very slow. But nowadays, the ability of collecting data in multiple forms has tremendously increased, and that has actually triggered to many of the solutions, whatever we are trying to see in this presentation. Right? So ability of collection of data has tremendously increased. That is an important factor. But there is another important factor which has combined with this particular data factor available is basically the ability to store the data and ability to compute the data. Okay, in olden days, people were having data, but they were not having enough amount of storage capacities. Right, they were not able to have hardware infrastructure. They were not able to have a lot of machines where they can store the data, right? With now the advent of big data, the availability of cloud computing and other things, uh, what we are getting right now is ability to store huge amounts of data. See, once I store the huge amounts of data, imagine I am taking an X-ray scan or MRI scan or a DNA sample scan. The DNA sample stores almost like 5 GB of information. So if you see, I do not have a laptop or I do not have a desktop which is able to store that. I have to throw that information. Right? Olden days we used to throw that information, but nowadays we are getting into the technological area where we are coming up with these cool technologies like big data, data science, and so on, cloud computing, and so on, which are providing an ability to store that information. Another thing which is also aiding them is the ability to do processing on the data. So storing is one part where I'm saying that I will have the big data systems, cloud computing systems, where I can store pieces of information in the bits and bytes in electronic memory, or the images, the videos, the WhatsApp messages, the comments on Amazon. So taking any information which is data can be now be stored. But we also have technologies which we will be discussing more detailed in today's presentation, that ability to understand or process my data and then get some meaningful insights. So that is all our data science is about. So where we are trying to get the data, store it in some storage, with the help of a lot of other technologies, and then run some algorithms where you can extract information from this data and then use it for some good business purpose. So that is a little bit of a data and why that is important at this particular stage. We are getting a lot of such information available, and we are getting a lot of such kind of tools and technologies and infrastructure, all that coming together. So we are in a fortunate era where we can make use of the data, where we can store the data, where we can analyze the data, get some meaningful insights of the data. So introducing data science is like I can say like it is a scientific method. It's a process. It's like we are running these different kinds of algorithms to extract this meaningful insights. So I was saying now data is available. Now imagine you have somebody who is saying that I have huge terabyte of storage. I can store this data. That is good. But data science come into play where I say that, okay, if I can extract this data, if I can extract some meaningful insights of the data, I can apply this XYZ algorithm so that I can predict what is going to happen in the future. So so the data science is the one which is able to tell all this kind of information. So the data could be structured data, like structured data in sense it is nicely sitting into an nicely nicely in a row column format. So structured data is basically data which can sit into a tables like Oracle tables, MySQL tables, and different types of tables are available. So we can say like first column is an integer, second column is a string, third column is a floating point number, like that. We will be able to structure our data. That data goes and sits into the table. That is called a structured data. And then unstructured data comes up like our videos, our voice signals. For example, I say, "Hey Alexa, can you tell me what is the best movie on Netflix?" Right? So it should it should go and then do some kind of query, and then it should come up back with some answer. I don't know whether it will answer that question, but certainly it will try to do some processing to understand that my question, understand what I'm asking, and then can fire a certain query on Google or their proprietary coding query processor, and then get back me the result. It can certainly give the results like, Alexa, what is the weather today? Right? It will give me back the answer. So data could be structured or unstructured, but what data science is doing is, when I store the data, how do I do the algorithms? How do I do the processes where I can extract some meaningful information of the data, create some applications which can work on that? Are we following, guys? Everybody? If you're following, just say okay or great or something like that. We'll continue.
Yes, sir.
So that is what we are understanding. So now data science becomes so important and essential that it involves a lot of these processes. Okay. So first thing is I have to capture the information as we are talking. Like imagine all these DNA samples taken. Imagine COVID is running. I want to take all the the basically what they call as the blood platelet information. So blood platelet information in COVID is very important because that actually carries the immunity levels of the people. Okay, and one more request, guys: if you are not speaking, can you go on mute, please? Because that will not hamper the quality of the presentation. Okay, please go on mute if you are not speaking. If you have any questions, please open up and then ask a question and then go back. Okay. Everybody, please go on mute. Or Raj, if there is a way where we can mute all of them, it will be great. But request everybody to go on mute. Okay.
Yeah, sure. Yeah, everybody, please mute yourself. Okay, only when you have doubts, you can answer using that. Okay, please.
So what we are seeing is this data science has multiple different processes, right? First one is I have to gather that information. So I was taking an example of COVID. So where I have to gather a lot of blood-based samples, I have to gather a lot of information regarding that and all of that, where I can gather this information about blood platelet level. And then the process of gathering this information involves a lot of things, like what all information to be captured, where it has to be captured, how it has to be extracted, do we need to do any processing on that, and so on. So that is the first capture process. Once we capture the information, you have to maintain it. So maintaining is the process where I keep the data somewhere, right? So traditionally nowadays we are having a lot of cloud computing based devices. In olden days, we used to store that on our own hardware system. So we have our own system. We create our own system. We store that data there, and then do some cleaning process and pre-processing and multiple other techniques are there where we are trying to extract meaningful information. Right? So yeah, guys are able to please mute up. Okay. Right. So the maintaining part is where I keep this data somewhere, and that may be my own system, my own server I create, or it could be a cloud server or somewhere where we'll keep this. Traditional name for that is called as data warehousing. So we keep that into a data warehousing system where I keep all my data, and then I do some processing like data cleansing, data pre-processing, and so on and so forth. Once we do all this processing, the next level is to understand or create some kind of modeling of my data. So understanding like different blood platelet levels, and based on that, we construct some kind of a immunity classifier, which tells that such kind of blood characteristics would have high level of immunity. Such kind of blood platelets would have low level of immunity. Right? So I'm trying to extrapolate these results. So based on those information, I will try to classify those kind of conditions, and then based on that, we try to come up with some kind of output. So there are a lot of data mining processes and algorithms which are used in process step, where we call it something like clustering and classification. So clustering talks about how do we group all your data where I group all a similar kind of patients who has similar kind of blood platelet levels of COVID. For example, they are all getting either sick or getting recovered from the disease. So we can group them together and then try to identify the similarities or patterns of the data. Maybe their age is good, their high immunity levels, they used to eat vegetarian, they used to have healthy lifestyle habits, like they don't smoke, they don't eat junk food and so on. So based on those all parameters, we try to group people accordingly. That is called as clustering techniques. So we try to cluster them, and then once we cluster them to multiple segments, I can use that information for further analysis, right? So there are a lot of these data mining techniques. I'm not going to go deeper into the first session, but just I want to make you understand that once I capture the information, once I maintain that information or store that information, next I'll do the processing of the information where I try to apply some modeling. And then once I apply the modeling, then I can then analyze the data. So from that modeling, we would be able to analyze that information, like say that, okay, this is how these are the type of the people who get sick for the COVID, or these are the type of the people who get a lot of immunity because so and so protein is very high in this particular people. The blood platelets have these signs of uh, you know uh, you know immunity, things like that, and all of those things can be analyzed. So once we analyze that thing, then we can construct some kind of reports. So these reports are nothing but you can draw visualizations. Like you see all these visualizations talking about different metrics about the data. Similarly, we can all draw these visualizations which will talk about how these immunity levels can be measured, and what immunity levels can cure people, what immunity levels can degrade the health of the people, and so on. All these things will come under the communication part. So imagine we are working as a project on this specific project. I will try to capture the data, I'll store the data, I'll run some algorithms to analyze the data. Once I got my analysis, I will construct some kind of graphs, reports, and so on to showcase that, results to my senior people, like could be managers or my company executives, or maybe government bodies or healthcare organizations or hospitals, anything. So I'll be able to report that information to a greater audience, right? A traditional data science lifecycle works like this: you capture, you maintain, you process, you analyze, you communicate the result, and then it goes in a loop. Probably, if there are some deviations in the report, then you try to eradicate them by doing better processing and so on, and then it follows that entire cycle. So there are certain skills which are required for big data and data science. We are trying to draw this. So this is a kind of a Venn diagram for having this combination of data science skills. So it would require a little understanding of computer science and IT. For example, I might need to know some base language. So I might need to know, like how to write code, like how to create variables, how to create functions, and so on. So I need to have an understanding of that, and then I need to have a good hands-on on um, guys having any questions here? Hello?
No, sir. No questions.
Can you guys respond? Are you able to hear me?
Yes, sir.
Can you guys respond if you guys are able to hear me?
Yes, sir. Your voice is audible.
Okay. Well, there was a little blip in the connection. I was just seeing that there was a message. So, okay, let me continue. The skills required for data science. So we would be requiring the computer science skills. For example, I need to know the language skills like how to write a code, how to define a basic variables, how to write functions, basic parts of the code. So one language is good enough. I'll be talking about the language of choice. The next important skill is understanding of mathematics and statistics. So many people say that mathematics is not that much required for data science, and that is not required. But that view is literally wrong, because all these models are actually based out of mathematical things and statistical inferences and so on. So we need to have a fair amount of understanding of what is the mathematics required for the data science, right? And in our course we will be having a good amount of portion of understanding the math and statistics required for data science. For example, there is something like linear algebra, there is something like calculus, differentiation and integration and so on. So those are like very, very scary subjects when we were doing our schooling, or probably plus one and plus two, because at that time we were not having an understanding of where do the this differentiation is used, right? But here in the data science, it is clearly visible, like where and how that particular technology is used, or that particular concept is used, right? So we will be going a very detailed approach about making the math and stats very, very easy in terms of data science perspective, right? We are very scared about mathematics, that, oh my God, I don't know like how to do it, or I really did very, very long time ago. I do not know. But that kind of fear will go away, and literally you would love to understand more mathematical concepts or statistical concepts related to the data science, because all we are trying to talk is more of an optimization problem. For example, I want to guess like how many cars Maruti will produce in the month of June, right? So in the month of June, which has not happened, it is going to happen in the month of June. And then looking at the current trend, current information, the problems we are facing in the current economy, the lockdowns, and all these things into consideration, we have to create a model, and then which is a futuristic model, and then that model will be able to predict like how many cars the company Maruti will produce in the month of June, right? So that is really, really exciting, right? So we are trying to do something which has not happened, and then we are mathematically bounding by some kind of algorithmic means to produce something which we have not seen right now, and we are going to show it in the future, right? That is what a data science engineer or a data scientist does, right? Uses these tools and techniques, uses the code, and uses the domain. I will talk about the domain, but math and statistics play a very vital role in doing this work. We're trying to do something like predictions, right? Going to predict something which is going to happen in the future, and then that is very, very exciting thing to do. And important concepts which are backing up those things are maths and statistics. And the third important wing is called as domain area. For example, I need to have an understanding about how the cars are sold in market, right? So I need to have some domain expertise. And people argue again, like the use of deep learning and other ones. We will talk about those algorithms. The newer algorithms, give some part of the world say that those algorithms are so intelligent that we do not require domain knowledge. I do not need to be a doctor to predict whether this is a cancerous case or not, right? So is it a malignant tumor or not? I don't need to be a doctor. But again, that kind of this thing also is a wrong perspective, because domain certainly gives a lot of information. Because out of like 20-30 columns of information which I'm getting from a report, I can, from a domain knowledge, I can clearly say that which columns are important and which columns are not, right? Imagine, take a simple example. I want to predict like how much loan I have to give it to a person. Okay, so you're working for a bank, and then you have to say like how much loan you have to give it to a person. Now, what are the input features you will take? You will take like what is your current bank balance, what is your monthly salary, what are your other liabilities, like do you have any other loans like personal loans or home loans or any other things? What is your marital status, right? Are you married? If married, do you have any kids? So these are all the information which are very, very important. But apart from these information, you might also have, because customer data collection is very huge. Like people when they start collecting customer information, they will collect X, Y, Z, A, B, C, D, everything of the customer. Like they will collect like what is the favorite color of favorite color of the customer, right? When is his birthday? Does he like ice cream or not? Does he like Shah Rukh Khan or not? Right? I'm trying to make a joke of this, but you're understanding when the customer data is collected, you collect plenty of information because we do not know when that information can be useful, right? For example, mobile number, the email address, and all these things are not helping me to decide whether, if my mobile number is a very fancy number, that doesn't tell like whether I will get a loan or not. You're getting it? Whether I have some very complex email ID or a very hackable email ID, that doesn't tell that you whether you will get a loan or not. So domain knowledge here plays a very important role. So domain knowledge experts, what they do is out of the given input variables, they can clearly tell that this variable, the bank balance, the salary of a person, the available loans, the marital status, number of kids and dependents. So these are all some of the important columns which will aid me to the prediction of a loan amount. You're getting how much loan amount I should give. Maybe the output is 5,25,000 is approved, but I have to derive to that. But for deriving to that, I need to use my domain expertise to tell that, okay, these are the important columns which will definitely give me a positive result in my output. Understood? So these are very, very important. You need to have a good backup of language. We will look at the language, and the mathematics is the math behind it, and the conjunction of your language and the mathematics, you call it as machine learning. Okay, we'll look at those things in great detail. Machine learning is more statistical programming technique by which it tries to understand the pattern of the data, and then using the pattern of the data, it will be able to predict the output result. So this is holistically what data science is all about. Any questions here? You guys following?
Following, no questions till now.
Okay. So let us understand what is how this data science has evolved. Okay, and fortunately, I've been in industry for quite a long time, and then I've worked in all these things as well. So when I joined as a fresher, I used to work as a mainframe developer. So mainframes, if you are not aware, it is a very robust technology. So we used to do coding on assembly language. It's a very, very powerful technology. We have many of the banks, many of your older institutions still run their mission critical applications on mainframe. So that is a warehouse, or like that is where a lot of data is hosted, and they have a lot of databases and all those things. If you have heard about a language called as COBOL, COBOL is one of the language which is used for this particular mainframe applications. In fact, it is a very centralized application. A lot of data is connected. A lot of applications are connected to a central source. So it is much more convoluted. You have a lot of things, checks and balances, bounds, and so on. So data processing used to become very, very convoluted. You have to use all the databases, file systems, and all of that. Then based on that, you create applications. And because languages were also not very heavy, we used to use COBOL and assembly, and they're not very data science friendly. So then later, what people did is they have moved out from the mainframe systems. Typically, they used to call as legacy modernization. So they moved out from legacy systems to data warehousing systems, where they have external table created. So the external tables will be used for doing data analysis, where front end tables, they are called as operational tables, they will be used for your applications. Like I have a banking application, or I have a retail application, or I have an insurance application, or a hotel booking application. So that is connecting to my front end tables. They are called as operational tables. And back end tables used to be there, which are used for our data analysis, right? Understanding patterns of the data, what is the supply, what is the demand, how I can do the forecasting. All those things used to do in something called as data warehouses. After the data warehouses matured, they have created business intelligence applications. So there are business intelligence applications like Cognos, Informatica. You have BI, or business objects, and multiple other business intelligence applications have developed. And they basically create some reports. They can create some dashboards. We can do some data visualizations. They do more or less something what we call as describing the as is state of the data. So what has already happened? For example, Maruti company wants to know like how many cars are sold in the month of January. Because January has already passed, I will be able to gather the data from my databases and then can show a report saying that this is statewide distribution of the sales of Maruti cars in so and so states. If that information is available with me, I can represent in a graph form or a report form and so on. That is called as business intelligence, like where you're trying to plot my data, and then I will be able to showcase like the as is state of the data. The next one is, people went a little beyond than describing your information. They went into something called as data mining stages, where data mining is trying to find out some relations between the data and then trying to give a little more meaningful informations of what business intelligence used to do. And nowadays we are using data analytics. Data analytics is combination of multiple tools. It is no more structured data analysis only. You can do structured, unstructured, typical different types of databases and different types of data. And then I can use it for doing future forecasting, predicting something which is going to happen in the future. As an example, I was saying how many cars will be sold in the month of June, which I don't know. That kind of analysis we can do it with the data analysis. That's how the entire data science is evolved. These are some of the important concepts which people need to understand. So people might have heard there is artificial intelligence, there is machine learning, there is deep learning, there is data science, and what are all these? Are they interlinked? Are they different? Because everywhere you see that people put some hoardings, people will run some campaigns that course on artificial intelligence, course on machine learning, course on data science, course on deep learning. They think that all these things are different, and then also try to fool people saying that these are different. The thing is that all are very interlinked, and artificial intelligence is like a bigger umbrella, right? It is more of a theoretical concept, and more of using rule-based guiding, right? If I create a rule-based guiding, say that if this is done, do this is done, do that. For example, if there is a file available in my system, then automatically trigger a program which can open the file, read the information, and then send the email to the people to the emails which are available in the file. Imagine you get a file every day in the morning, and then I have to build a system automatically. It has to read that file. There will be some emails in that particular file, and then I have to send a welcome email to them. Right? So this is a part of the job. If I'm trying to create a system which runs based on this rule-based processing, that typically will be called as an artificial intelligence, right? Where a human is not involved. People also have created a different name called as automation. In olden days, that is an AI system, artificial intelligence system, which is governed by some set of rules. So you create some set of rules and processes. Then based on these rules and processes, you can automatically do some work. You might see there are robotic automated processes, right? You have bigger, huge manufacturing plants which has this common set of processes which are happening. The robot or machinery will do this common set of processes, probably like creating package boxes, right? So it has to turn this cardboards into packaged box. So you can pass a normal cardboard, and then it will take the cardboard, create it into the shape of a box, and then it will pass it out. So what is it doing is, if it gets a shape of a cardboard of n cross n size, then based on the dimensions of it, it will try to take correct measurements and then try to fold it into a box, and then it will pass it forward. So that kind of systems are called as artificial intelligence systems. Most of them are guided using some rule-based, logic-based, some if-then-else condition-based approach. Understood? That is artificial intelligence. Now, if those rules can be, if these rules can be identified from the machine itself, that is called as machine learning. Okay, so I'm not automatically giving the rules. I just give the data. The machine can understand from the data, like what are these rules, what are these conditions based on which I can take the decision, what are the conditions based on which I can fold a board. Imagine I create a video of a person who is automatically folding a board, and then I show this video to somebody like a machine. Then machine looks at the hand movements of the folding of the board, and then it will understand the pattern by its own, and then next it applies that folding. If that is something which is happening, that comes under machine learning. So machine learning is a science where we use algorithms, a lot of these processes, and all these processes, what they will do is they convert, they basically create this create these automated systems where they can where they can create these algorithms which can do futuristic predictions and so on. So that is what machine learning, and machine learning is very well with structured data. Coming to deep learning, what it does is, with the new advancements of data storages, a lot of new data is coming up, right? Data like videos, data like images, data like different other processes. All these processes, what we are trying to do is, like, if I want to look at an image and then I can tag that this is my friend, you might have seen in Facebook, it will automatically do the friend tagging. Like, how the hell it understood like this is my friend? Like, because if I have already loaded his images previously and I've already tagged him, later it will identify the face recognition. Based on that, it will automatically tag that this is the same friend. You might have the phones where it is identifying the facial recognition and then it is unlocking the phone. How did it understand? It understands my facial features, understand where my eyes, ears, nose are there, and based on that, it will match my facial photograph with all my previous entries, and then based on that, it will turn it on. Now, if a car is moving on a road, if it is a self-driving car, it looks at a traffic signal. If the traffic signal is red, it has to stop. And how does it looks at a traffic signal, a red, blue, green thing, and then understand this is a red signal and the car has to stop? How is it doing that, right? So all these things basically are part of your deep learning technology. So using your images, using your videos, using all these things, what we are trying to do is we are trying to create deep learning based systems. And deep learning based systems uses very sophisticated data for creating more complicated systems. Got it? Just a second, guys. If you have any questions, please post.
So what is basically deep learning?
Just a second. Just post it. I'll talk about
Yes, guys, whatever doubts you have, please post it in the chat window. Okay. Sir will be answering it soon.
The question was, what is deep learning? As I told, right? If you want to design a car which can look at the traffic signal and then understand that this is a red signal, and then based on the red signal, it has to go forward, right? That is one of the application of deep learning. Okay, if I want to look at the photograph and say that this is a photograph of a dog or a cat or a bicycle or something. If I want to look at that and then do that object detection, that is a deep. If I want to look at a sophisticated diabetic retinopathy image, which is taken by a image a scanner at a specific eye hospital, right? Shankar Netralaya or some eye hospital has taken this diabetic scan of our eye, retinal scan. And they're looking at the retinal scan with different blood vessels and different other voids and cysts form in the blood. I have to identify whether the person has diabetic retinopathy or not. Now, diabetic retinopathy is a specific kind of a disease which, when you have higher levels of diabetics, it will impact your eyesight. Right? Technically, you will over the years you will lose eyesight. So it can be early detected, provided you take the proper retinal scans. And in India, with the help of Google and other technologies, people are creating centers in multiple eye hospitals, right? Like Shankar Netralaya, Arvind Eye Hospital, and all different eye hospitals are there. It basically takes the scans of eye. So you have to people go sit before the scanner. They take the eye scan, and then that scan will be sent to the computer. The computer can look at the diabetic images, and then it has already got a lot of diabetic eye images, and then compare those eye images with the current pictures, and then says whether that particular eye image is diabetic or not. Early detection of diabetes is also identified by that, and it's a very, very fascinating application which Google has done. Google has created a tool called as Verily, and that is a deep learning based application which does this image recognition. These are some of the noted applications. So those are some of the noted applications, and there are plenty of them. For now, we can discuss about this. Any other questions? I will be able to answer them. Let me check. Raj, if there are any questions, we can read it out. I'm having a hard time to look at the already.
Or I'll read it out. Okay, 1 second.
Questions.
So there's a question that is artificial intelligence used vastly in data science, or is it machine learning we use?
As I told, artificial intelligence is a bigger umbrella, right? So if I'm saying I'm using artificial intelligence, if I'm saying I'm using machine learning, technically I'm using artificial intelligence. If I'm saying I'm using deep learning, technically I'm using artificial intelligence. Like, it is a subsystem. It is a sub area of artificial intelligence. Artificial intelligence is more of a theoretical rule-based process. But if those rules are by default identified by code and tools, software, then that is either called machine learning or deep learning. Where machine learning primarily focuses on business data, most of the data is structured in nature. As I told, I want to guess like how many cars will be sold in month of June, and how much loan I should give. So these are all our business questions, and that could be solved with machine learning. But the diabetic retinopathy example, which I was saying, which is more of an image classification or image identification, that can be done with deep learning.
Okay. So there's a question that how data science is related to AI, machine learning, and deep learning.
So there are different names to it. As I said, the technical parts are machine learning and deep learning. But if a business person is talking, he is talking about more of a forecasting, more of a supply demand analysis, more of a prediction, and so on. So data science is a business oriented term, and data science is little more different from whatever machine learning or deep learning does. Machine learning, deep learning, and artificial intelligence are algorithmic process. So there are mathematical, algorithmic, code-oriented process to get some prediction done. But data science is a little beyond that. For example, it also involves in the process of getting the data. Like, I have to get the data, I have to clean the data, prepare the data, then you give it to a machine learning model to do the prediction. Once a data is predicted, I have to showcase this result. I have to, create some report. So you see, this data science is a pipeline. Okay, from a business perspective, I want an answer for a certain thing. So right from the secretion of a data till the dissemination of the reports or the information, you can call it as data science. But if I use a tool, a specific tool which does certain things, like a prediction of the loan amount, that is just the machine learning part. But how the data is segregated, what tables I curate, how I clean that information, how I present the data, it's all about data science. And in fact, we have some slides for that, but I hope that clarified the answer.
Okay, there's one more question. So it is like, is the traffic signal an example for embedded systems application?
Depends. Most of those devices are used for edge detections. For example, I can't host a bigger cloud connected system. I can't run a bigger machine on my car. So most of those systems are technically called as embedded, not embedded, but edge devices. We call it edge devices, where I can put my machine learning, deep learning logic on the edge devices. They can do this work, right? So you can, yes, you can call it, because physically these mechanical and electronic based devices are doing that work. So you can call it embedded application, but they're all related. You see that which device is running my model, how is it getting images, and then how is it processing. All these things are connected. So a Tesla car is doing this. It has a 360-degree camera, and then it can take the data, do the processing, and then give back the results. So that you can call it as embedded, but the technical name for that is edge program, edge machine learning. Got it? So let us go forward. I think we'll answer more questions later. For now, I think it should be good. So there will be one really important question people will have is, what is business analysis and what is business analytics? Okay, so just the business is same. So if you play like a flames game or something, you cut out all the common things, and then whatever is left out is there. So if you see business is same, the analysis and analytics is also looks same, but what is the difference? And many people have this big question. So business analysis is more a process oriented term, that more of people who are creating the processes, more of an organizational purpose, creating how the work has to be done, how my team should work, and it's a more of a process related things, like how this entire thing should work. Okay, that is called as business analysis. Like if I want to bring in a change product, if I want to bring in a new product, like what all the keys and components and dots to be connected for that change in the product, there is a lot of analysis which is required, and that typically forms as a business analysis. The key focus on processes, key techniques and functions, different methodologies, which are adopted, and all those things, we call it as business analysis. Generally, people like business analysts, functional analysts, system analysts, if you have these kind of title names, they are doing this work. Their primary goal and responsibility is to become like a a kind of an become like a connector between the actual business and the technical teams, right? They will be taking the business requirements, they will be understanding what business requires, based on that formulating some ideas, creating projects, and then getting the projects done. So those are all the business analysis folks. We're coming to the business analytics. Business analytics is more a specified division where we're trying to focus on the future decision making. Like, for example, I talk about example of how many cars were Maruti sold in the month of June. That is a question which can be solved by business analytics folks. So they can be specific people who knows good amount of statistics, advanced mathematics. They will have computer knowledge. They will be able to create models, create this algorithmic based statistical models which can predict some things which is going to happen in the future. They will be also part of big business making, decision making teams, the part of big data, data driven solutions and forecasting and all of that. They will be the ones who will be doing all that work. I think that is the key difference, and people always get this kind of confusion, like what is business analysis and what is business analytics, right? I hope now you got a little understanding. Let me do the classification of data analysis. It is like four-step process. It's a four-step process. A lot of detailed information is required. In fact, one class would not suffice us, but because this is a first kind of a session, I'm trying to show like what is it doing. It is like four sections. First is descriptive analytics, diagnostic analysis, predictive analysis, and prescriptive analysis. Descriptive analysis is just a second. I'm sorry. So descriptive analysis, as we described, this is generally a thing of as-is analysis. For example, I have that information. I want to show what has already happened. The prime question which will be asked is what has already happened. So it will take the data which is already in hand, and then based on that, it will be able to create some reports. It will be able to create some charts, graphs, and so on, by which we will be able to describe the as-is state. That is called as descriptive analysis. There is something called as diagnostic analysis. Diagnostic analysis is a little difficult than descriptive analysis. What it will do is, if it has something, we have to question like what happened. Okay, so when the question comes that why did it happen, like if something happened, like for example, the sales of the cars went down in June or May. The second question comes is why did the car sales went down? If that question comes, that forms under something called as diagnostic analysis. We want to know why something happened like that. Okay, in many business scenarios, you can ask this question. For example, a customer moving from Airtel to Jio. The question comes to the Airtel person that why did the person moved from Airtel to Jio? Okay, there could be 100 different answers. That is a very difficult question to answer right now. But that question or that nature of question is called as diagnostic analysis. Okay? And we will try to identify the patterns in which the movement happened. Probably that could be the customer is not satisfied. There's a lot of call breakage. He's paying more than what his competitors are paying or whatever his friends are paying. So he wants to do the churn. So that could be the reason. The third one is predictive analytics. Predictive analysis comes at the futuristic level. It's more like a forecast. It's more like a prediction of what is going to happen. Right? Predictive analytics answers the main question like what will happen? What will happen in the future? Right? So, for example, who will be the customers who are likely to buy my product? That is a futuristic thing. Who are the students who are likely to attend my course? That is a futuristic thing. So that forms under the predictive analysis. So we are trying to predict, like based on all the things which we have in hand, based on all the responses, based on all the interest and other things, like what is the likelihood of something going to happen in the future? That is a predictive analysis. And the last one, which is even more difficult, which has a more feedback kind of a mechanism, is called as prescriptive analysis. Prescriptive analysis will say like, what can we do to either make it happen or not to make it happen. For example, say for Airtel churn analysis, people moving from Airtel to Jio. I'm just taking an example. I'm not biased towards Airtel or Jio. In fact, I have my Airtel connection and I also have Jio, but I'm not biased towards it. I'm just taking an example. Imagine a person moving from Airtel to Jio. Then there could be a question like, what can I do not to make that happen, right? So that is called as prescriptive analysis. So you have to do this. You have to do some create your own, create a strategy in which you increase the data package, reduce the pricing without compromising on the return on investment, multiple other things. Based on that, we can come up with a strategy which will help focus customers to actually have a feedback mechanism of what can be done to avoid this scenario. Got it, guys? Descriptive analysis means tells the what is condition, current as is condition, what has happened now, and what is the current data. As per the current information, you will be able to tell the statistics. For example, I know the COVID cases. Descriptive statistics will tell the number of records of how many survived, how many dead, how many different other statistics, whatever we are seeing. All those form under descriptive statistics. Based on the descriptive statistics, we try to do diagnostic statistics, like why did this happen? Like there could be, we did not flatten the curve pretty well, and because of that, there was an explosion of number of cases. So that all forms under diagnostic analysis. What will happen? Predictive analysis is what is the expectation that number of cases in the month of June, July, August, September, and so on. Based on the current trend, based on the market conditions, the way the people behavior, social economic conditions, and so on, what is going to happen in the future? That is called as predictive analysis. What should we do to avoid that particular state or to go to that particular state? So, maintain social distancing, don't go outside unless until it is very much required. Ensure that all, kids and elderly are taken care of, and all these things, right? These are all the steps of prescriptive analysis, which will reduce the increase in the current situation. Understanding, guys? Those are all part of your different types of classification and different types of analysis, which will be done using this classification problems. Okay. Let us discuss about if I am trying to do a data science project, what are the different steps which are involved in data science project? Okay, this is a little related to what we have done previously, but typically many people will have this kind of a myth that data science means doing machine learning. Data science means doing deep learning. This is what people will have a great myth, but that is not true at all. Data science, most of the work, typically 70 to 80% of the work will depend upon how do you collect the data, how do you define the problem, how do you prepare the data, how do you do exploratory data analysis. All these things have a greater weightage than the modeling part. Modeling is the phase where you apply a machine learning model or a deep learning model. This is the phase where we apply that modeling. But there are 4 different phases before that. For example, I want to define a business problem. What is a business problem which I want to solve? I want to reduce the churn of Airtel customers by 20% next quarter. That is a business problem. Okay, so you have to set that success criteria. I want to reduce the churn by 20%. Okay, now we will have a clear data science objective. So I want to reduce the churn of the customers from A to B by 20% in next quarter. That is what your business problem talks about. How do you map that particular business problem to your data science related area? So how do you map that? What all data you have and how that data will be helping you to predict the churn prediction, and how that will help you in assisting this problem is a mapping problem. Like how do you map that? Which algorithm to select? Now, what are the data points to select? What are the different types of data you take? Whether they are categorical variables, whether they are numerical values, what are the information you are able to collect? That is all about your mapping. So step number 2. Step number 3 talks about data preparation. Data preparation is a very, very important step. It will try to collect important information, because if I pass garbage to my model could be so good. Okay, it is the best of the best state of the art model. But if I pass a garbage to that model, it will give garbage result. That means that wrong predictions. So data preparation becomes a huge important area where we have to take care about what data will be collected, what are the strategies on cleaning the data, what is the required transformations. For example, data might be in a different shape. I might have to transform into a different shape and sizes and so on. There are different techniques in this data preparation process where we will use like different types of scaling techniques, different types of normalization techniques. All those things will be performed to make the data in a clean, nice format. So I don't want to give garbage to my model. If I give garbage to my model, I'll get garbage result. Okay, so I'll do all this pre-processing, make the process ready. Then I do some other statistical visualization techniques called as exploratory data analysis. So we will learn a lot of tools in Python like NumPy, Pandas, and Matplotlib, and so on. And using those tools and statistical visualization techniques, we will be able to understand the patterns of my data. Okay, so if I am able to plot some graphs of my data, the relations between the data, I can clearly see some kind of patterns in my data, whether the data is so much convoluted, whether the data is having clear differentiation of data points, or whether I can easily able to predict my output or not. So all these kind of exploratory questions, like how is the data flowing? Is it positively correlated? Is it negatively correlated? Is it having any sinusoidal graphing? How is the curvature of the data points? Is it like parabolic or different other functions are required to understand my data? So once I understand my data properly, then using that understanding, we can choose appropriate model. A model is a machine learning model. Now, that step is called as modeling. Modeling is like you apply any machine learning model or a deep learning model to create an what we call as to create a classifier or regressor we call, right? So that will help you in doing the predictions. After the modeling, we have to evaluate my model. Right? Now I create a model, and then I am predicting that so falana stock, for example, I take a stock, say Reliance Industries. Okay, Reliance Industries currently it is around 1200, and I say by the end of this month, Reliance Industries will go to 1500. Okay, so I'll run my machine learning model or run my data science model. I will predict based on all my factors. I'll do all this work, map my business problem. My business problem is to understand what will be the stock price of Reliance Industries by end of May. And then I do all the data collection, do all these things, apply the modeling, and then I'll predict that by end of May, the Reliance Industries will be 1500 rupees per stock price. Now the stock can be more than 1500, stock can be less than 1500, and that I will only know by the end of May. Now it is only what 9th or 10th, 9th, right? So by the end of May only I'll know that. So once we get to know the actual result, then I will calculate the difference between the actual value and the predicted value. My model has predicted something, and the actual will come something. So actual, imagine it is coming at $1,600, 1,600 rupees. So I predicted 1500, actually 1600. The error is 100 rupees. You got it what I'm saying? I want to predict the stock price of Reliance Industries. I predicted it will go to 1500 rupees, but because of some macroeconomic things and all, it shooted up to 1600 rupees. And then the error of what my prediction is doing and what is the actual result, it is 100 rupees. So that 100 rupees has to be corrected next time so that it will probably my model has not considered some factor because of which that 100 rupees error came. So we have to do this evaluation. Evaluation is nothing but identify the how accurate my model is, so that I can correct my model to understand the other parameters as well. Right? So it is a continuous process. It is not like a one-time process. You see that it is a continuous process. This evaluation goes back. You might have to capture some things you might have not captured. So it is a loop. It is like an iteration. It loops through multiple steps. You might have to capture more information. So if the evaluation is very bad, imagine the accuracy is like somewhere around 60%, or the error is so much. Actual value of my company is, I'm predicting it will be 1300 and the actual company went to 2000. At Reliance went to 2000. I have predicted 1300. 700 is the error. 700 rupees is the error, which is very bad. right? So depending upon that, we try to iterate as a process. Once we iterate through this procedure, I will get more better result. I will try to understand more parameters, more features. So the data science entire workflow is an iterative process where we try to improve on my model day in, day out. We try to feed more information, try to feed more data. Based on that, you try to get better results. Understood, guys? Are we clear?
Yes, sir.
Right? Let me go forward. So as you're seeing, important thing is like 80% of the work is done in this phase, 20% of the work is done in the modeling and then evaluation phase. So that is clearly explained by Pareto principle. So if you know, Pareto principle is nothing but um, 80% or so. So for doing any work, so in general in a life, this thing, the Pareto principle is applicable everywhere. Most of the thing will be done by only 20% of your effort or work or people or anything, right? So out of the 100%, most of the thing is done by 20% people. So even if you see in offices, most of the work, so if I take daily work, most of the actual work is done in my 20% of the time. Rest of the 80% of the time is like maintaining other things and so on, right? So like more of task related stuff and so on. So you can go to Google and then just search the Pareto principle. It is a very beautifully explained life principle. So which says that most of the work will be done by 20% of your effort or work or people. So that is exactly following in the data science workflow. 80% of the work is done by this part of the this thing, and then 20% is done by the machine learning one. So let us look at what are the tools which are used in data science. Okay, so tools which are used in data science, there are plenty of them. Recently, we are using a lot of tools. So we have big data tools like Apache Spark. We have NoSQL tools like Cassandra. We have different other tools like RapidMiner. You can write some code in SQL. You have databases like Hadoop, file systems like Hadoop. We have tools like R and Python, which are languages which I can do a lot of coding. You have visualization tools like Shiny. We have distributions like Anaconda, where we have multiple Python related packages and libraries connected together for doing a lot of processing, right? So using all of these together, you can create a very complicated ecosystem which can do data secretion, which we can do data pre-processing, data analysis, and prediction, and so on. A lot of such kind of tools are used. Currently, the market demand is rising for data scientists. A lot of job opportunities are there across the world. There are, even if the market is like slowing down, you see there are a lot of current job opportunities for mid-level data scientists, entry-level data scientists, senior level data scientists, data engineers, and so on. There's a lot of market demand, and that's the reason. And this particular technology is going to stay for. I anticipate that this is going to stay for at least like 10 years from now, right? So because as you see, most of these tools, whatever we are creating, are in a very nascent stage, a very early stage. And if we get into a company which is working in data science, which is doing some, either it could be a startup or it could be an established service company or it could be an established product-based company. If you get into such kind of companies, you would be able to work on data science problems, and it is going to stay for coming many, many years. So the trend in so if you are comparing with other jobs, like the trend in the data science, machine learning engineer is going at a very rapid pace, right? So you see that there are different. This is computed from a lot of metrics which we collected. And if you're seeing, there is a lot of information for different engineers. So different full stack engineers, big data engineers, data scientists, and machine learning engineers. And you see that 9.8% X times is what we are getting for machine learning engineers, getting considerable same 6.x times number of demands. So this is the demand in the number of jobs we are getting for data scientists. And the salaries for the data scientists is also tremendously more when compared to any regular software engineer. So it is also becoming lucrative for somebody who wants to get into this field, that while they are doing very exciting work, at the same time they are heavily paid by companies, because there is a lot of unavailability of talent who can do the work of a data scientist. And getting into that kind of a job or responsibility will certainly bring into a bring your career into a different level. Now the question comes is like how to become a data scientist. Right? So there are multiple ways of becoming a data scientist. You might be a graduate, you might be completing your bachelor's or master's, or you might be already working for some company. So what you have to do is you have to tune up yourself for equipping into the skills which are required for data scientists. So our course, whatever we are delivering for data science, it is fully functional course. It is like a very sophisticated, practical oriented course, which will give you complete information of, right from the ground zero to become a hero, right? So you have to skill up, right? Unless and until you have that skills, it will be difficult for you to get placed as a data analyst or a junior data scientist and so on, right? So you need to get the necessary skills. And then once you have the skills, the sky is the limit. In fact, many companies are looking for people at different levels, and you would be able to get into those jobs provided you have the required skills. On the required skills can only be achieved or acquired when you do the practice which is required, when you get the right amount of mentoring, right amount of coaching. All those things will be provided, but tune up. So these are some of the skills. You need to have a good logical reasoning. You need to have the analytical skills, the hard skills to understand the data movements, ingenuity. You have math required skills, and of course the communication skills, which are very very important for communicating your results. And this is as per the Glassdoor survey. An average US salary, it's around $141,000, and it's a really good salary, a high paid job, and less number of people working in that particular skill. So it's very lucrative. Look into what are the tools which are used. In fact, what is the languages which are used in data science? These are some of the languages. So you need to know C, Excel. There are some big data related tools like Hive, Scala, and so on. Hadoop, Spark are also topping the chart. But top of the list is the language Python. Python is a very versatile language. It is a super duper language. There is also a close competitor called as R. When compared to R, Python has taken the edge because it has this connectivity to multiple other systems. You can create APIs, you can create websites, you will be able to launch the applications, you can publish the applications onto cloud. It has interconnectivity with many, many other systems. So because of this, it is becoming very, very popular in the developer community. And one other important thing is that you have bigger companies like Google, which is like releasing a lot of toolset. For example, a deep learning toolset called as TensorFlow is released in Python. Similarly, Facebook has released PyTorch in Python. So there are a lot of these frameworks which we can do a lot of machine learning and deep learning, work using these libraries, and all of these are open source libraries. So you have everything available at your disposal. You just have to use those technologies. You just have to use those libraries to get your work done. And because of this, there is a heavy demand of Python, and it is staying in the top position right now. So why Python? I'm already talking about it. Python is a versatile language. I can create websites. I can create games using it. I can create APIs. I can write testing functions. I can create automation jobs. I can create machine learning models and deep learning models. So name it, we can do it, right? So it is so versatile that I can do all those things with Python. So if I want to create a machine learning model, say like I want to create a loan approving application, right? I want to look at the look at the data points given by the customer, like his age, salary, monthly balance, and all those things, and then I have to predict how much loan amount he has to get. So if I want to build this application, I can't just create a model and then keep it, right? I have to create the model, get this model connected to a front-end web application, which can take the customer information, pass the information to the model as an API. Model has to predict the answer, give back the answer to the web application, and web application will show the result. It will say that congratulations, Sitaram, you are approved. Loan amount is 5,25,000. Click this button for the dispersal. You're getting? So we have to create these end-to-end applications. Like I want to create a mobile application which can, call a backend model, and the mobile application I will show crops which are having pests. Okay, so I have to show the mobile to a crop. I will open up my camera and then I show it to a crop. It will look at the crop. It will have some pest. It will identify the type of the pest, and then it will first identify the type of the pest, and then it will recommend the pesticides which are required to be sprayed on those pests. Understanding? So this is a mobile application. Now, how do I create a mobile application which can call a backend Python service as an API? It can, pass an image to that API. The Python application, deep learning application, will look at the image, identify what type of pest is what type of pests are there for the plants, and then it will identify the type of pests, and accordingly it will recommend the suitable fertilizers or suitable pesticides, not fertilizers, pesticides for spraying on those pests. You're able to connect it. So all these things, so Python is very versatile. So because of this versatility, you can do a lot of this kind of programming, and then you can use it for a lot of processing. Okay, so that is very, very important. So another, we will just talk about the statistics, importance of statistics, and then I will take some questions. I'll give 10 minutes for the questions to be answered. So statistics is very important. Statistics in data science is also very complex, because statistics is the art of science of understanding data. So data can give a lot of flavors. It can give a lot of clues or information. So the clues can be analyzed by understanding their inherent statistical models. How is the data behaving? Is it a positive relation? Is it a negative relation? Is it showing some kind of a graph, some kind of peculiarity? All those things we can analyze from the statistics of the data. Got it? So that is how it is very, very important. In our course also, we'll understand statistical inferences, all the models, all those things we will be covering in the course. So that is very important for a data scientist. Okay, so with this, I will close it. I would wish, if there are any questions, I will take questions and then answer them. Can you ask the questions? Probably I'll back.
Yes, guys. Any doubts, any queries you have, you can ask him. Sir will be able to clarify everything, all the doubts regarding data science or the tools or whatever doubts you have regarding that. Please. Anybody, you can use the chat window as well, or you can ask directly.
Yeah. So we'll give it a few minutes.
Yeah.
Sir, what is the difference between data scientist and data analyst?
Data analyst is a general term. So for example, I want to read the data from tables, I want to create reports, and so on and so forth. Data analyst will be doing that job. So key skills of a data analyst would be Excel sheets, doing SQL queries, reading the data, creating the reports. All those things will be the key skills of a data analyst. A data scientist is more a little technical person, as we saw that he will be able to create these models, he'll be able to create the predictions, forecasts, and so on. That will be done by data scientists.
Okay, sir.
If I need a primary question analysis, the data analyst will be doing. So generally, whoever will be junior level people, like freshers or so on, primarily they will be given data analyst roles. Okay, so they will be doing a little better data science analysis. They know the things, and then they will do general data analysis work, where doing basic things, and then getting into that and getting into machine learning engineer, and then progressing as a junior data scientist, and then senior data scientist, and so on. Right? Please come tomorrow, because I will be talking about all these roles and important parts. But tomorrow we have at the same time. Please don't miss that. We will be talking about those important roles which are important, and what are the application areas where we'll be using data science. We will be discussing about that. So please don't miss it tomorrow.
Yes, Sitaram, there are small doubts here in the chat window. Can you check that out?
Yeah, I'm just seeing it. So significance of R programming in data analysis. So as I told, R is mostly used, in fact, a couple of years back, say like 2012 and around, R was primarily a very focused language for doing data science, right? Because everybody was doing statistical analysis, and that became primary choice of usage. But back then, data analysis was only limited for creating reports, analysis, and so on. But nowadays, it is much more than that. Now I am talking to Alexa to do some work, right? Give me an answer. So it is much more than what we are trying to think. So R has not got that kind of flexibility, and that's the reason it has slowed down in the process. But nevertheless, R has a lot of penetration in statistical modeling, like in areas like finance, in areas like bioinformatics, and different other areas. You use a lot of R programming. But when compared to Python programming, it has taken a backstage because of all these additional stuff which we have with Python. So non-statistical people can become data scientists. In fact, anybody can become data scientist. Only that you need to have understanding of mathematics. You need to have understanding of all these models, and then how they are applicable to those models, right? So for a statistical people, or like who have done their done MSc statistics or things like that, it will be easy for them. But generally, engineers are taken into this role because this is not just a statistical tool. You might also have to design systems. You have to create end-to-end machine learning systems which can be deployed. So for that, you need an engineering skill. So that's the reason engineering people are preferred. I mean, say engineers and different kind of skill set people.
So,
I'm not sure who are the audience, but I'm just giving my view. Okay. So is Python a tool for data analysis or a language? Python is a language which is used for creating data science tools. And which one is better? If you ask me, Python is better. And why, I already explained so much, right? Why Python is better. I'm planning for MS in coming September. Just want to know how can I be well prepared so that I face no difficulties when I get into the master. It depends upon what would be your area of interest. If you're going for data science and masters in data science, a lot of colleges offer that, or there is also masters in business analytics. A lot of colleges offer that. It depends upon what you're planning to do. If you're going to masters in data science, this particular course will be really good. What I want you to do is, I don't recommend a course, but what I want you to do is to do a lot of practice. You need to have a lot of hands-on projects. What the people who are going to masters, they have to keep in mind is, they have to be employed after the 2 years. Like we are not going to time pass, spend our father's money to going to US and all, right? US or any other country. The reason is you have to be very focused. You have to get so in the first semester you will get these internships, and then you have to be very focused to get into those internships. The only way you'll be going to get into those internships is if you have any hands-on experience. You have to get some projects in your resume. You have to create a GitHub profile, keep it active, keep the learning going on, create a lot of projects, as many projects as you can, and then publish them into GitHub profile. Expand your LinkedIn profile. Do connect with a lot of good people around your space in the data science, machine learning, and so on. Follow them, try to comment on them, give your own analysis, create small projects, project them on the LinkedIn. So this is a way in which you can get employed, right? And that is very important, because if the thing gets slowed down because of all these pandemic and other things, you want to get employed, right? And the only way you can get it is by getting right from the day one. I would recommend to have good knowledge on data science, get as many of the projects done. Once you have that caliber, believe me, people will come for you. You don't have to go for the project. People will come for you. So you have to get into that kind of a shoe. How can EC students go for data scientist? What is the route map? So basically for EC students, so there is a mixed bag of people, and I have seen so many people who have done EC. In fact, I believe EC people, as a general tendency, have more caliber than regular other engineering grads. So whatever I see, okay, this is my personal view. Okay, I'm not an EC guy, but because I've worked for so many years, I've interacted with so many people. So they have a little more caliber or in the work nature, but only thing that they will be learning in the part of their engineering, fortunately or unfortunately, they'll be learning different things like VLSI design, image processing, business signal processing, and communication things and all. So which might not be in direct connect with these things. But nowadays, what is happening is there are a lot of this intermingled courses. For example, IoT, I take. Like somebody was asking me the embedded thing, like is it coming into embedded or not, right? So that is such kind of work is done. Imagine I want to identify, I want to create a Raspberry Pi based model which can look at crop and then detect whether it is a weed or not, and then create a robotic arm which can pluck up the weed and then throw it out, right? So there are a lot of such projects which are developed and which requires a heavy electronics or communication related skill sets. And only people who can solve that is the EC guys, right? So if you're already done your engineering, that is great. You can get some projects done in data science here, and that would clear your path. But if you're doing your engineering, then what I would recommend is you have to do some projects in this space, like your interest area and data science combined together, and create projects for that. Right? So that will be my recommendation. Any other questions?
Okay, guys, if you have any other doubts or queries, please do ask. We shall be winding up the session now. If there isn't anything else, please let us know in the comment box, please.
Basically, I'm BA economics student. So do you think I should take up the course?
BA economics, see, I would recommend you at least, I hope you, do you have any background on programming language or anything of that sort?
Zero background.
Okay. See, BA economics people will be able to get into the finance domain, where you can become business analyst in the finance domain. So you could work for a bank or any NBFC or any financial organization, or work for any chartered accountant based this thing, who are working in pure data analytic role for analyzing data, right? So that could be your role. So in those cases, you have to at least have a background of some programming language. I would I would suggest you to get into Python. Learning Python is not very, very hard. It is pretty easy. But if your thought process is into get into that kind of a direction, like where you want to be not just shaping as an economic person, but becoming somebody like a chartered accountant, or working for that group who is trying to do some predictions, working for a big financial company within India, or there are a lot of other financial companies who are working in India. US companies like Franklin Templeton, Bank of America, JP Morgan Chase, Goldman Sachs. There are a lot of these companies who require the BA economic person, right? If they have these skills, then certainly that would be an edge. But for that, you need to prepare yourselves, because your course might not have anything of the language part. So I would recommend you to do the preparation, which will certainly help you in the future. So there is a question like, what are the important skills to have in Python with regards to data analysis? So there are all the tools which are required for doing data analysis with Python. I will cover in the course. There are some libraries which are required. You need to have a basic understanding of creating a language. For example, how to create functions, how to create programming constructs, and all those things. If you are able to do that, then you should be good enough. But all the Python skills, whatever are required, I'll be teaching in the course. So there is
There's
another
one.
question: being a system
Yes, there's one
administrator.
more doubt. Yeah. Go on.
Yeah, being a system administrator, can I shift into data scientist career? So if required, so what you want to do is, if there is a path where you can become from a system administration to a Hadoop administrator, or a data science administrator, or a cloud administrator, and then get into data science, that is a pathway. I have known many friends who have done this, because there a direct jump would require you to have the programming skill. If you have the programming skill, then you can find out a pathway where you can directly be a administrator for a data science workflow, because there are a lot of database administrators, big data administrators who know data science, who build algorithms, but their prime roles will be administrating the entire pipeline and creating systems and so on. So I would recommend you need to have the understanding of the data science. You and your pathway, if you want to really go into that space, right? Because this space is going to stay for a longer time. Being a system administrator, if you are really aware that there are a lot of ingestion of cloud systems right now, and many of the monotonous jobs which a general sysad used to do, those are getting automated right now, right? So if you want to stay in your own role for a very longer time, either you want to upgrade yourself into a cloud-based system or a data science-based system, or else what we see is those kind of jobs can get obsolete in the coming future, right? All these things are getting automated, so it becomes really difficult for a heavier survival. So I really recommend to just think about it, that what is your goal point, like what you want to do. Then based on that, you take a decision. But certainly, it is possible. I told the pathway, right? You to get into big data systems, probably like administrator, and then get slowly transition into data science. But getting into the big data system also, you need to understand all. Let us understand what will the data scientists do at various work locations. So where do they actually work? So this is a very it is not a niche job. It is like a universal job. A lot of companies might require these. So the government companies, the tech companies, research and development organizations, college and universities would require a lot of normal, uh, low, mid, and medium range companies would require software companies. Software companies would require data scientists. Delivery companies, service-based companies, all those things would require data scientists for doing their day-to-day work. These are all the different companies which can help data scientists to give some job. Now let us look at various industry roles in data science. So there are different roles a person can play in a data science. For example, he could be a business person who is trying to get requirements from the clients or from their quoting customers, understanding the business, and then getting the change request for the business. So that could be a business person. It could be a data science analyst. It could be a researcher. It could be an infrastructure engineer, which is setting up that entire infrastructure required for data science. He could be a data science developer who is doing model building, testing the model, evaluation of the model, all those things. He could be a machine learning specialist who is like handling the end-to-end data science workflow, where he'll be able to create the model, deploy the model, fine-tune the model, and run it. And then there could be a big data analyst. Big data analyst would set up your entire big data ecosystem, and there could be a general data scientist. Now we will look at all these individual roles and see where all these different roles fit. So the data science developers, these are the ones who are developing the code. So these would be creating the code. They will be understanding the mathematical models, statistical models. They will be using R and Python language for creating their entire pipelines and creating your entire step process. So that is the job of your data science developers. Now, there will be a thin line between all these individual roles, depending upon the size of the company, the nature of work, and all these different aspects. The role can change, but the roles are having this very thin line between each of those roles. Sometimes there could be data science developers, could be data scientists, or they could be called as machine learning engineers or junior data scientist, data analyst. So people will call in different ways depending upon the size and the requirement of the project. So data science developer is the one like basic level who will be doing all this basic development. Infrastructure engineers are very crucial because they are the ones who are setting up the infrastructure required for data science. They will be either on-premise infrastructure engineer or cloud-based infrastructure engineer. So on-premise means they will procure the hardware, set up the machines, install the softwares, making it enable for a data science pipeline to run. But if they are cloud engineers, what they will do is they will be knowing one of the cloud platforms, AWS or Azure or Google Cloud, and they will be helping in setting up the cloud infrastructure so that data science engineers or data scientists can utilize that hardware or software, then use it for their actual purpose. So these guys will be setting up your systems. They will be monitoring the systems. They might have to ensure that the systems are available 24/7. There are no downtimes, because if there are downtimes, the corresponding data science engineers cannot work. These are the ones who are playing that crucial role of ensuring that the infrastructure is up and running 24/7. This is the second set of roles. The third set of role is the machine learning specialist. Now he's the one who is creating your models, who is doing the prescriptive, predictive, and diagnostic based analytical models using our machine learning. And he's the one which is using multiple data mining techniques. He will be the one who interacts with the business, gets the requirements, and convert that requirement into an individual project, get the project done, and then develop into a full-fledged system. Right. So these are all. This is how the machine learning specialist would work. And big data specialist. So big data specialist is the one who is doing all the data ingestion. So yesterday we were trying to understand a little bit about this differentiation. So big data engineer is the one who is getting the data for the data scientist to work. So data ingestion talks about gathering the information, storing the information, and processing the information. We might have to set up a lot of huge infrastructures, which could be set up by the infrastructure engineer. But the big data guy will actually connect to multiple systems, source systems, and then bring the data from the multiple systems to a central place. Once the data is gathered at a central place, then then a data science engineer or a data science machine learning engineer can work on the data and then create the models. So the big data engineer, you can think like he's the person who is handing over the job to a data scientist, and then a data scientist takes the data and then analyze the data and produce the results. Sometime again, as I said, there will be overlap. People as a big data engineer can also understand data science workflow. They might be doing some data science part of the jobs as well. But depending upon the size of the company and the requirement of the project, the roles vary differently. That is about the big data engineer. Next one are these researchers. Now researchers, they are these domain experts. They have some good understanding of the domain. They know like the art and science behind the data. So they will be able to derive some insights, get some models, create some strategies, identify trends and patterns. So they will be having this kind of an understanding of creating those kind of insights to the company. They might not have a lot of knowledge on IT infrastructure. They might not be doing a lot of coding and computer science and so on. They might not be a lot of hands-on, but they will be using some of the other tools for doing deriving insights and getting an understanding on the models and so on. So that is so that is the work of the researchers. Coming to the data science analyst, so the data science analyst is to perform your regular day-to-day jobs. So this guy is the one who is doing basic data analysis, might be getting data retrieval from the tables or flat files or Excel sheets, and so he will be doing the basic analysis, and probably he would also be creating some data visualizations, prepare the reports, and then send that reports to the higher up to the higher officials, and then based on that, the further analysis will be done. That is the role of a data science analyst. Now, the business person, as we understood, business person is one who manages your data science project. Now, he's the one who gives the requirements. He might not know a lot of technical details, but he will be the one who will be driving this entire initiative. He will be the one who is giving requirement. He will be the one who is validating your models, who is validating your results, providing some feedback, and all those things will be provided by the business person. Next one is a data scientist. Now, data scientist is a generalized term. So he will be the one who might know the full stack data science work. So he might be the one who is getting the data. He might be the one who is creating the models. He might can also create some visualization reports. He might create the models which can be created as an APIs and can be served by the front end applications. So all these kind of work, like a full stack person, that is the person who is a data scientist. A data scientist is the one who basically does all that work, and he will be the one who actually work on different aspects of data science workflow. So that covers about the different roles. So are there any questions on the roles, whatever we have covered about data science, data scientist, machine learning engineer, business person, big data engineer, infrastructure engineer? Any questions on this?
No questions.
Okay. So we will continue. We will understand about the different applications of data science. There are plenty of applications of the data science. In fact, if you continue talking about those different applications, it would take so many hours just for understanding various applications and where data science is used. But
I have
because
a
of
small
the
question. Sorry.
yeah, go ahead.
Yeah. As I understood the rules you have explained before, can we focus on just one of the rules and expertise in that and get a job only in that, or should we learn all of those to get even a job in one expertise?
No, all rules are not required. In fact, doing that would also be foolish. So, depending upon your skill set, depending upon where you're coming from, imagine you love to do coding and like love to do analysis and so on, then you would like to become a machine learning engineer. So if you are a general purpose guy who has a little seniority in the team, you might already have some experience. Then a data science engineer, junior data science, or a senior data science engineer, or a data scientist would be a right set of role. Imagine you have a lot of infrastructure background, you worked as an admin or things like that, then maybe like an infrastructure engineer or a big data engineer could be a best role, right? So
So we
depending
can,
on where you're coming from, those kind of roles could be chosen.
yeah, so we can focus on anything what we're interested, right? On out of all those.
Correct, correct.
Yeah, thank you.
Okay, any other questions?
Yes, sir, I have a question.
Mm-hmm.
Sir, before choosing a data science field, what are the things and what are the qualities and what are the things we required to in ourselves to go by choosing this language?
So, to become a data scientist, so what I would say is you should have a innate ability to understand data. You should have the inquisitiveness to look at the data, try to find patterns. You should have this analytical skills of figuring out the patterns and so on. So that, imagine in the childhood we used to play this puzzle games, and then puzzle games is like you're trying to identify different uh, pieces of puzzles, and then I'm trying to identify like where is which is going to fit and where. So that is more like an analytical skill. So if you have some kind of that kind of inclination toward analytical thinking and doing work, then data science would be a good process. So to get into data science, the question has two parts, right? What type of people can do, and then second, to get into the data science, you might require, depending upon the role you are entering, you might require to do some coding. In the coding, probably you can use some basics language like Python, which is a very easy to learn language, very interesting language, a versatile language. We can use one of the language, and using that, you can create some basic coding. And nowadays, the industry is so going at a very fast pace that a lot of tools are coming up in the industry. So a data scientist might not do a lot of coding also in the future. He will be doing the work using one or the other tools which he is equipped of. So using those tools, he will be able to perform multiple analysis, right? So such kind of things could be done in the future, and we could do such kind of analysis, and it will be helping us. So to answer the question, people should have a basic knowledge of some programming. They should have the inquisitiveness to do analysis, identify patterns, and so on, and then should have some little background about like understanding math and statistics, right? So if you have that base understanding about math and statistics, how to use those things in the real world, that will it will be an added advantage, right? These are some of the qualities I would say.
Okay, sir, thank you.
Got it? Any other questions before we get into the applications?
Question, sir.
Okay, then. So let us get into the applications of data science. There are plenty of applications of data science. If you look at every industry will have one or the other application area which is covering data science. So I'm just listing a couple of them. We'll go into detail about these applications. So we have like fraud and risk detection. We can do like intruder detection use cases. We have a healthcare, which is a predominant sector in which the data science is used. We have internet and internet search and optimization based use cases. We have in marketing, we have targeted advertisement. We have website recommendation, or generally the recommendation engines. We have advanced image recognition, speech recognition, airline routing planning, and gaming, augmented reality. You name it, every industry area is having some or the other applications which uses data science. So we'll go into a little deeper, understand what are these application areas. First, the fraud and risk detection. So many of the banking, insurance, and other companies actually do this work very. This is a very important work for do. So risk assessment, identifying risks and frauds is a very critical thing for banking or financial companies, and they invest heavily in data science for doing this kind of a work. So what it will do is, so if you generally think like they use a lot of technique like anomaly detection, and similarly to identify anomalies are nothing but, so the data points which are very different from the regular transaction, those are called as anomalies. So if you see, you're doing a bank transaction. Imagine you are a normal person. You regularly go to a grocery shop, buy some milk, buy some atta, buy some, different vegetables and so on. And you go to a gas station, fill up some petrol, and then you go to a hotel once in a week and go to movie once in a week and so on. So imagine this is your traditional lifestyle. Then out of your lifestyle, imagine you decided to buy a 4K television. Imagine it is like 2 lakh rupees. So your card, you use it for a regular purpose, and imagine you swipe that same card for buying a television which is like 2 lakh worth of rupees. Then what happens is there is a sudden anomaly which is triggered. And this anomaly is like when comparing your past transactions, you never spend so much in a trigger in a day, or probably never you have spent such kind of things, but you intended to do that spending, right? But that anomaly will be triggered, and then you will be notified either via a call or an email, or your credit card or a debit card get automatically blocked, and then you get a call from the bank saying that, sir, we have seen a transaction of 2 lakhs on your card. Can you please validate whether that is you or not, right? So such kind of mechanisms are put into place because previously people were doing the cyber stealing, where when anonymously the data will be stolen by the hacker, and then you really don't know whether that is an anomaly. So what the banks do is they try to do anomaly detection, where they identify an anomaly which is also called as an outlier, and outlier is detected, which is following this trend in the data science, where we try to identify the base trend, which is like a regular spending pattern of a person, and an anomaly for that particular person. If you are identifying some anomalies, those will be flagged, and system will take actions accordingly. Either send an email, block a credit card, or do a call. So likewise, you can do different types of fraud and risk detection techniques. Another application area which uses is called as healthcare. Healthcare is predominantly using your data. So medical image analysis, for example, there is something called as diabetic retinopathy. So you're taking medical samples of your eye, you're taking retinal scans of your eye, and then within that retinal scans, you're trying to identify whether the person is having diabetes or not. Right. So the person has diabetic retinopathy. What happens is the person will lose the eyesight. When it is increasing, the person having diabetes that is increasing, eventually the guy will lose the eyesight, and that is dangerous, and it is also identifiable at early stage. So diabetic retinopathy is generally takes a simple image of your retina, and then based on that you pass it to a machine learning model which identifies whether the particular eye has diabetes or not, or diabetic retinopathy or not. Based on that, and it can also create pinpointed identification marks, like where does it think it has diabetic things, and then based on that you can be having some medication which can cure those kind of tissue cells which are becoming over diabetic, or it can cure those kind of causes. Similarly, medical image analysis is like becoming so common that it is used for a lot of medical images. For example, I can use it for an MRI scan. I can use it for a CT scan. I can use it for an X-ray to identify whether there is a broken limb or not. So all these kind of operations, which used to be very manually intensive, it used a lot of subject matter expert from a doctor, now are being now are being replaced with systems which are equipped with medical these things. And then what those systems will do is it will give a information to the doctor. So the one who is actually taking the decision is doctor, but these applications are aiding the doctor to do some better, create some better outcomes. Right? That is what a doctor will do. And second important field is called as drug development, a very very important field. And what this do is drug development is basically we're trying to predict a specific drug component or drug compound is good for a specific treatment or not. Right? Imagine we're trying to test a drug for COVID-19.
Excuse me, sir. I have a question.
Yes.
Sir, before you actually yes, you told that in retinopathy the person is losing the eyesight. It also can be at the application of data science. So if person is losing the eyesight, it is not means it is not that sure that that person having a diabetic. It may be the other reason. So how data science would able to recognize that it is a diabetic person or a normal person who means it is losing the eyesight.
Yeah. So I think the question is like the person can lose eyesight for some other reason also, not the diabetic. Is that correct?
Yes, sir. How can? Yeah.
Yeah. So basically, so what it does is this is purely based on the data. So you collect a lot of images of different diabetic retinopathy patients. Okay. So if the science says that the diabetic retinopathy patients, your eyeballs will have different smaller cotton kind of spots in the eyes, in the blood vessels of eyes, basically trying to clot your blood vessels and slowly deteriorating your eyesight. So if you see a lot of images of diabetic eye cases, these are all prominent, very, very prominent. Right? If I give a new image which does not have diabetic retinopathy, right, then the person will say that it is not diabetic retinopathy, and the eyesight, whatever is lost, is not because of diabetic retinopathy. So it can clearly distinguish that angle. So then, there could be some hereditary or some other kind of, retinal distraction or some other kind of a shock based on which the eyesight could have been lost. Right? So doctors will come up with that kind of information. Right? So what diabetic retinopathy will do is, provided you have diabetes, provided you are getting into that phase of diabetic retinopathy, you are in the early stage, that thing could be recognized by the machine and then can alert both doctor and the patient so that they can take preventive medication. Understood? Understood, guys?
Yes, I understood.
Right. So the second one is the drug development, which is very important because the drug discovery, what we call as drug discovery, is nothing but you're trying to identify like how much time it will take for the drug to come into the market. So that is the phase in which the drug is tested, and then you have identified the drug. But for the drug to come into the market, it has to take some clinical trials. You have to do multiple round of tests and so on. So that typically takes a lot of time, right? Imagine you are inventing a drug for fever and headache, say like crocin. You're inventing a crocin, and I can't invent the dosage of crocin and then can use it on patients directly. If I use it, there could be different consequences of that. The patient can die, the patient can have severe side effects, and the patients can sue the drug company, and then they will get into the lawsuits and all of that. So that is a bigger problem. So what the drug companies means the pharmaceutical companies. Okay. So what they do is they will have a series of tests, and only when the tests are approved by Food and Drug Authority, then they can release that drug onto the market. So they will test it on different animals, like on rats and rabbits and monkeys and so on, and then try to see that if the drug is perfect for humans. They also sign up some NDA agreements with humans that they will undergo some clinical trials, and the humans have to sign that, saying that, okay, I understand that this is a new drug. I am risking my life to test this because I really need that. Imagine some COVID patient and who is almost in the deathbed, and then he really wanted a good medication, and then he will sign that particular agreement saying that I am okay to sign this, and I hope I'll get cured with this. Based on that, he will sign it, and then he will take the medication. Imagine there are some side effects; those side effects should be taken care, but ideally, that kind of a drug will cure the person. Okay, the drug development cycle generally takes a lot of time. What these data science can do is it can create those model simulations which can speed up your process. So what it will do is, imagine you do something like gene analysis. So you try to identify the genes of rats with the genes of humans, and then try to see which genes are similar. So that is part of your data science, where we are trying to do pattern matching and then identifying which genes are similar. And then if I say like, okay, these genes of rats are similar to the genes of humans, then I will try to test the drug on the rat and then see what is the reaction of those genes. If those genes are reacting positively, then we can take an extrapolation that the same genes will be reacting positively when tested on humans. Right? So such kind of analysis will be done, and then using that analysis, we can do a lot of such kind of tests, which is which has which has speeded the processing of drug development. And the same techniques are being also used in COVID, identifying vaccine for COVID and so on. A lot of research is going on in this area. Now, genetics and genomics also fall under the same category. We just discussed about this, like identifying similarities of the genes and the DNA samples and so on. Those are also falling under the same category. Now, the second one is the virtual assistants, customer, and so on. And this virtual assistants or customer support, basically using a chatbot based things, right? So rather than we ourselves doing the analysis, we are trying to take a chatbot which basically does the analysis for us, and then we use it for our purpose. So automatically understanding what people are talking, automatically remembering the state of the conversation. So all these things are done by data science. So we have a lot of these chatbots created in the recent past, which can do some very very mundane tasks like booking a hotel room, booking a flight, or to doing a very, very complicated task like doing some bank transaction, analyzing our result, and then producing some information, detecting defects in the software lifecycle. So such kind of applications are created which can be handled by these chatbot based agents. So internet search is very very dominated by the data science algorithms, because you see that this is the industry which has created a lot of algorithms. So you name the services like Google, Facebook or YouTube, or based on things where it is basically creating algorithms which can first index the data items very quickly and then send the data items to the query result within a fraction of seconds. So just imagine if you just write a letter A in the Google search, go and write A in the Google search and hit an enter. So you would see that it will say that some billion pages are queried, and then you are getting the results of the letter A. So with just a letter A, you're doing so much of query. Just imagine if I'm doing a very complicated query of multiple words and keywords and so on, it could take even more time. But if you see that it is taking very, very less time, and all is that because using data science and related algorithms to foster heuristic searches, which will give best results in a very less time. Another one very interesting application area is in the marketing domain, where we want to identify the right set of audience for my product, right? So digital marketing is very very important, but you need to understand that you are spending. So we will be spending some amount for doing the marketing. Now, if I want to reduce this digital marketing spend by targeting the right amount of audience, either I do all the hard work, identify like what are my right set of audience, do a lot of survey questions, and come to a conclusion that okay, these kind of audience will be a right set for me. So that is one way. The second one is based on my clicks of the user behavior. Imagine who are clicking my website, who are clicking my post, who are looking at my product. Depending upon all these kind of analysis, we can get the user demographics, and then based on the user demographics, we can arrive at a user base who would be using my product. Like somebody who is electronically freak, and then who is like electronic savvy, they might be having age group of some say like 20 to maybe like 35, 40, something like that. Some after that people will be much more stable. I don't say like older people are not technically or savvy, electronic savvy people. They are, but most of the group, you see that the younger generation would have this tech savvy guys. More of them tech savvy, right? Newer updates they will be picking up very very quickly. So, if I want to sell a product which is more a tech savvy product, then I would be concentrating on the audience who would be purchasing that. So, based on the user behavior, I will be identifying who is my target audience. And then for that target audience, I'll be giving my recommendations. Next one is the website recommendation. Now, you might have seen this. This is very, very common that this says that people who are buying this mobile is also buying this scratch guard and this case, right? So you want to buy a new mobile, you get this kind of recommendations, right? Now how these recommendations are possible is because of this thing, right? Where we are trying to create systems in which we are able to do these recommendations, and then the recommendations are based on your past behavior. So what we try to do is we try to do something called association rule mining. It's a machine learning technique in which we're trying to do associations between the products. And then if I find out a very high correlation or high association between the products, then I can say that people who buy a product A can also buy a product B and can also buy a product C. So that is dependent upon the associations between the product. That will give a very very nice information. Similarly, there is another application like advanced image recognition, where you're trying to identify what is in the image. Right now, this could be used as image processing, or it could be also used as video-based analytics. Now, if at all, so there are a lot of projects in this space. For example, so some governments are creating these kind of projects to identify potholes on the roads. Okay, so identifying potholes on the roads is a trivial problem. So imagine I keep a camera in my dashboard of a municipal vehicle, which goes throughout all the streets of the of that particular area. Is there a question?
Yes, so basically, what you do in website recommendation? What is it? What kind of process is it? Website recommendation.
It is called as association rule mining.
Yes, sir.
Okay.
Okay, sir.
Great. So association rule mining is a technique in which we are trying to find out associations between the products. Now, once I find very strong association, I can do a lot of things. Now, I can also do combo offers. If people who are buying this toothpaste, you get this toothbrush for 50% off. You see these kind of offers, right? Now, how do they come up with these associations? Like, how do they know that people who are buying toothpaste will certainly buy a toothbrush? It's a very common this thing, right? So because most of the people who are buying toothpaste, some or the other time they have to buy toothbrush, and then if they see that there is this 50% offer, even if they are not interested to buy the toothbrush, they will certainly go with it because they see there is a value in it. It's a human tendency. So finding the association, there are a lot of strategies which are used. So once I find the association, I can give it as a recommendation. Like you get it in Netflix, you get it in YouTube, right? Imagine you are seeing all cricket related videos in YouTube. The next few days you get only the cricket recommendation, right? So like how is Kohli playing and how is other guys playing. So you get all these same kind of recommendations. Imagine you're learning about data science, right? You're going through multiple videos on data science and then doing some learning on data science. You continuously get those kind of recommendations. Imagine you look at a Saas Bahu serial or some soap on the YouTube, you get similar recommendations. You see some comedy act or something, a Kapil Sharma show or something like that, you get similar things. The
Excuse me,
thing,
sir.
yeah,
Sir, I have a question that in day by day in our mobile system, there is a face recognition system is there present. By using face, we can unlock the phone.
correct.
So, can we say that it is the application of data science,
Yes, it is
or
an
we can
application.
say, or we can say that it is the application of deep learning?
As I told, deep learning is a subset of data science, right? So when I say it is an application of data science, it is also an application of deep learning. So if you want which exactly it is an application, it is an application of deep learning. Got it? But
Okay, sir.
holistically, I can say it is an application of data science.
Okay, sir.
So that is what we are talking here. So the image recognition, whatever we are trying to recognize, the same application is the face recognition. So in our in our mobile phones, you are able to identify your faces, and then based on that, it will unlock, right? So that is a feature of deep learning, which is basically identifying our face, and based on that, triggering a input to the phone to unlock it. So that is how it works. There are multiple applications, multiple related applications to it. We are just talking a few. Another one is speech recognition. Again, this is one of the famous applications which is used right now. For example, I can say, "Hey Alexa, what is the weather today?" Right? So Alexa will listen to my speech, and then it will decode my question, and then it will come back with an answer that today's temperature is 32 degrees centigrade, right? So now there are multiple pieces to it. First one, it has to decode the speech signal. It has to construct a question from the speech signal, convert that into a text, and then fire a query to either Google or any other popular search engine, get a result, and then construct the query back in the form of a voice, right? So you have multiple pieces of data science applications used here, which can construct the entire Alexa application. There are tools which is part of AWS Amazon, which does multiple things. There is something like AWS Amazon Lex. There is something called as Amazon Poly. Amazon Lex is like for converting the chat-based interfaces. There is Amazon Poly, which converts your text into a speech. Like so many applications are there, internal applications which does this work, which are driven by deep learning based framework. In early years, these frameworks were not working so great. You know, somebody talk Indian English, the applications doesn't used to remember, like doesn't used to recognize what the question was. And nowadays, even if small babies talk, it is able to understand what they are asking, right? And then based on that, you can uh, respond back with the output. Got it? Next one, it is airline route planning. Again, route planning is like, which is the best route, based on the information provided, the fastest route, the best route for travel without any delays. So all these kind of techniques are used for airline industry. Now, this is also used for example, delivery industry, home delivery. For example, an Amazon package has to be delivered. packages to be delivered to you, your friend, and different neighboring places. So, like how the truck has to go. So that is also one of the problem solving, which is available in deep learning. It's called as a traveling salesman problem, a typical data structure problem. That is also modeled using data science, and then which can give approximate distances, time, and route calculation for doing this route planning, airline route planning or passenger route planning, the delivery route planning, and so on. All those things could be used in this. Right. So that is about some of the application areas. There are plenty of them. I could go talk for hours and hours and cover about those applications. But for now, I have limited our applications on what could be used. So I'll just cover about a little bit about the data science masters in data science course. So this course is having multiple live projects. So you will be doing a lot of live projects and whatever things we have spoken so far. There are plenty of live projects in machine learning, in deep learning, natural language processing, and different other things. We would be using Python as a language, and you can use Python for doing all this coding. And there are so you can get certified. In fact, you would be there are a lot of internationally acclaimed certifications which you can, after the course, you can get those certifications done, and then you can get certified as a data science professional. And you would be able to you would also get a certification from TuneUp, where you would be recognized as a data science course completed graduate, where you could use it for further further your job or any increment or any other project change and so on, for those kind of things. There are plenty of access of tools. There are a lot of live support available. So we would be connecting. Either you can connect us on a call, or probably you can drop us an email. Then we will be able to provide you the live support and mentoring. If at all you're doing some project, there are plenty of assignments and projects also will be conducted. So if you have any questions with the assignment or the projects or any of them, you will be able to contact us for the live support. These are all some of the features. So why choose TuneUp? I think this is a very comprehensive course. We have industry trained experts who are actually delivering the courses, not like somebody who just learned data science from somewhere and then speaking up. We have these industry oriented live projects. The projects are very real time. They really know like how we are implementing the projects. We're trying to give best in class learning management system, where you will be able to get into the class, have the recorded sessions, videos, and so on. You can acquainted with your process. I would also give a couple of minutes for Raj and somebody to also speak on this. So this is like the contact for TuneUp. So if you have any questions, you can contact this number, or you can drop us an email at info@mytuneup.in. So any general information, I would like Raj to talk about it. Before that, I would like to take any questions you might have. Any general questions you might have, I would like to take those things. And then I'll hand over to Raj to just talk about some of these concepts in detail.
Yes, guys. Any doubts you have, any queries, you can please ask. Anything regarding the course or regarding the technicalities, anything you can ask, please. Okay, so no doubts, I guess. So anybody's typing here? Okay, nobody. Okay, there's a doubt here. Speech recognition is the example of signal and system.
No, I see there is an echo.
Okay. Uh-huh.
Can everyone go on mute? Maybe Raj, you can just speak up.
Is it okay now?
Yeah.
Okay. So there's a question that speech recognition is the example of signal and system.
Signal and system.
Yeah.
I did not understand the question. The person who
It's
has
like is speech recognition an example of signal and system?
talking about the electronics and communication subject. Is that what he's asking?
Yes, probably. I think.
Yeah. So see the in ECE, electronics and communication engineering, there are multiple similar concepts. So there is digital signal processing. There is also multiple subjects on signals and systems and so on. So that subjects will teach us like how to synthesize the uh, voice. Like there are multiple things which will be taught for synthesizing the voice. And once those data points are collected, deep learning algorithms can be run on that to identify what the voice is saying and what the whose the voice is it. Like for example, I am talking to my imagine a scenario, a hypothetical scenario, which I'm very sure that it will be coming in the future. I will be talking to the TV, and then I'll say, TV, cricket chalu kar. Then it will start cricket, and then it will understand that Sitaram is speaking, and then based on my like and all that stuff, it will turn on the TV with that channel in that. Imagine my mom comes and then she asks that, open the Saas Bahu serial or something like that. And it will understand my mom's voice and then it can again change that based on the preference, right? And it might have some kind of a priority level. Mom's Saas Bahu is much more greater than my cricket. So that will be changing based on that understanding, right? So where it is understanding the signal or it is understanding the voice modularity, the intonation, and multiple other qualities of the voice, and then understand who the person is. That is first thing. And then second thing is understanding what the voice is saying, and then breaking that into a question. And then based on that, performing that action is the second part. Most of the systems we are seeing, it is doing the second part. The first part, where still in research area, a lot of work is happening that understanding multiple tones, intonations, and then understanding tagging a person to it. Like our face recognition, face ID, you will also have a voice ID. Might come in the future where I can speak and then it will know like okay, Sitaram is speaking. Similarly, somebody else can speak and then understand that guy is. It is a part of it. And there is a lot of, but beyond that, doing all this work is a part of deep learning.
Sir, hello.
Yeah.
Sir, I have a question. You said that Sitaraman is speaking and data science would able to recognize which voice is it's from. So my question is that, sir, if someone is speaking like you in your same voice, is data science is able to recognize is Sitaraman is speaking or some other people is speaking? Because that person is speaking same voice like you.
Hmm. Yeah, that is a trivial problem. Now we have these comedians and mimicry artists who can speak like people, right? So that is a trivial this thing. But for that, we need a lot of data. Now we need to give a lot of data to recognize that, right? Now the question comes in same as like if I have a face recognition ID and we are twins, like I show my face and then it is opening up my mobile phone, but I have a twin brother. I can show his face and then still opens the mobile phone. That is a security threat, right? So it's still now we will still have such kind of problems, but the data science can evolve to a greater level to understand minute details. But for that, we need to get a lot of data in first place. Then once we get a lot of data in the first place, the minute differences which we as a person might not be able to understand can be understood by the model. For that, what we have to give is we have to give a lot of samples of real Sitaram's speech and a lot of samples of fake speech by somebody else like Sitaram, right? Once we get both of them and then say that this is real, this is fake, then it will try to understand like what are the patterns in the real speech and what are the patterns in the speech which is not real. There could be some places there will be some differences which could be very minute where we are not able to identify, but the model will certainly able to identify. But for that, you need to have good amount of data. This is the same problem had in the uh, early speech recognition systems where it was not able to understand Indian English and different English of say kids and so on. So but it has evolved a lot. A lot of many people are speaking, and then it has evolved. Similarly, it will also evolve for such kind of process.
Okay, sir.
Any other question, guys?
There's a question here. 1 second. So, how does data cleaning play a vital role in analysis?
Data cleaning plays a very, very important role. As I was telling, I'm not sure if I used this word. If I give garbage to my model, you will get a garbage result. Okay, that is very certain. Because modeling is so it is all mathematical thing, and it is trying to identify patterns in the data. Imagine I did not clean the data and I give some data which is not value added. Okay. I'm saying when not value added means something which is not relevant for my prediction. Then what happens is model technically goes and tries to understand that what is important in the data, which is not which is not value added. Okay. So for example, my email address, uh, my column email address for predicting my loan amount. Like if I have very peculiar email address, very lengthy email address, or a short email address, or a fancy email address, or a cool dude email address, right? Doesn't matter, right? If I have different type of email address, it doesn't matter whether I will get my loan or not. So that email address is called as a non-value added column. So if I don't clean that column, what happens is my machine learning model will be thinking that there is something in the email address which is helping me to predict how much loan I will get. Okay, so it will bang his head like anything to try to identify that pattern. Like it will get plenty of email address, right? So first name dot last name is a typical type, but cool dude and Princey something like Diva or something like that. There could be different kind of email addresses, right? So machine learning model will be banging its head to identify different patterns in the email address and how is it contributing to predict how much loan amount a person is getting. So if I don't remove that, then what the model will be doing is it will spend a lot of time analyzing that, and then it will give back the result, which can be little deviation, which is a little deviation also, because this if the data which is not cleaned up, we call it as noise. The noise means like which is not relevant to whatever I'm requiring, and then it is giving some falto direction to the model, and the model will be searching in a different direction where it has to search in the other way. So it might be spending more time, more effort, more computation. In return, it is giving inaccurate result. So data cleaning is very, very important. If you don't do with a single line, I can say if you give garbage to the model, it will give you garbage result. So that is very important. Understood, guys?
Okay, guys, any other doubts? Any other queries? So, we'll be winding up the session now. If you have anything, you can let us know.
Hello.
Yeah.
Sir, as you mentioned in previous slide, healthcare, how does SVM work in medical applications or medical analysis?
So the SVM models typically, yeah, you can go on mute. Okay, great. So SVM models, what they do is they are used for classification and regression problems. So if I want to identify medical information, typically what we do is you construct the data get the data from, say, images or videos or any other information, and then construct vectors of your information, and then run SVM algorithms on that. So when you run SVM algorithms are very well suited for sparse data where not a lot of data points are covered. Okay. So what they will do is they'll do internal transformations. SVM algorithms are very, very good in running these transformations where they transform your data from one space to another space, and then where you can do the classifications of your images or videos, or maybe any data points like medical related data points. It can take all of that data and then do the classification algorithms on that. So basic preparation of the data will be done by some algorithms, data preparation algorithms. Then we can feed that prepared data to SVM algorithms so that it can use it for prediction. In fact, not only SVM, we can also use other algorithms like random forest, XGBoost, support vector, logistic regression. Like that, there are plenty of algorithms which could be used for the same purpose. Got it? So any general questions about the course or anything of that sort? If you're interested, just let me know.
Yes, guys. Any other questions? Yeah. The recording will be provided to you soon. No, unfortunately, the slides won't be provided because of the company policy, but we'll be providing you the entire session recording. Okay, don't worry about that. Okay, anything else? I guess that will be all. So thanks, Mr. Sitaram, for such a wonderful and such a informative webinar on workshop on this particular topic. And I'm sure all the students have gained a vast amount of knowledge regarding the technical aspects as well as the industrial aspects of data science and artificial intelligence and machine learning. Thanks a lot.
Thank you very much.
Excuse me.
Yeah. Who has a doubt? I think. Yeah.
And actually, I have. Can I the slides which are displaying? Can you repeat the slide so that I take the screenshot of this?
Which slide?
Slide only.
Which one?
So today's slide, the slide which is displayed today in this lecture. So can you repeat this slide so that I can take the screenshot?
Yeah, we'll be sharing you the recording.
Yes, recording will be shared, right? So you can take it from there.
Yeah. So the entire recording would be shared to you. You can just go through that. Okay. Okay, guys. Anything else? Okay, so this was just a brief overview of all the various aspects of data science and all the different industrial trends. Okay, when you go for the course, we'll be having in-depth training sessions on each particular topic. We'll be starting from the scratch, from Python, then you'll be going into data science, then you'll be learning machine learning, deep learning, artificial intelligence, then you'll be having industrial projects. So all these are included in a curriculum. Okay, so we have LMS system, we have 100% placement assistants, we have industrial experts as trainers, as data scientists. Okay, so all these things will be provided, and also we'll be assisting you for certifications as well. Okay, to get into the industry as a reputed data scientist. Okay, so all these things will be provided from our side, and we'll be expecting the same hard work and dedication from your side. Okay, any other doubts, you can contact us on a mobile number, as well as you can contact us on WhatsApp. We already shared you the brochure, you can go through that. Any other doubts, please feel free to contact us. And I thank you a lot for all these wonderful questions and being such an amazing crowd. Your cooperation was very helpful in order to this workshop to be very successful. And I thank you everyone again.